Welcome my viewer. I want to take you through chemistry practical that was done December 2022 last year. This is the paper that was done. Let us jump inside and see what it had. You are provided with the following: solution A indicator. This was methyl orange indicator. This one was methyl orange indicator. Solution B, 0.05 molar compound B. Solution C1, hydrochloric acid, to be used in question 1A and B. So procedure 1. Place 2 test tubes in a test tube rack. To the first test tube, place about 2 cm cube of solution B. To the second test tube, place about 2 cm cube of solution C1. Add 2 drops of indicator solution A to each of the test tube. Shake and note the color of each solution. Record the colors. So the students were supposed to record the color. Solution B, which we don't know, plus indicator A, the color was yellow. So the students needed to write what they see, the observation. Solution C1 plus indicator solution A, the color was pink. You should note the color of indicators in different solutions. If the solution is an acid or a base, different indicators in naphthalene and orange, methyl orange, they change depending on the solution. So you should know that. Complete the following statement. In the titration of solution B in a conical flask with hydrochloric acid solution indicator solution A, the color changes at the end point is from, the color changed from yellow to pink. So these are the 3 marks that the students were supposed to get to pink. Procedure 2. Using a pipette and a pipette filler, pipette 25 centimeters of 25 centimeters cube of solution C1. C1, remember, is an acid HCl. You should know that. Into a 250 centimeters cube ml, 250 ml volumetric flask. Add distilled water to the mark. Label this solution C2. Fill the purette. Now in the purette we have C2. Using a clean pipette filler, place 25 centimeters cube of solution B in a 250 ml conical flask. Titrate solution B with solution C using 3 drops of indicator solution A. Record the results in the table. So after doing that, these were the values. This was the values, our values, because each school could have their own values, so don't worry about the value. This number doesn't matter. You can use N and you will score the marks. Calculate the average volume of solution C2. So when you see this one, it doesn't mean that if you got 14, it is wrong. If you got even 20 centimeters cube as an average, still it is fine. An average volume of solution C2. So now let us calculate average. Remember, average it is 13.6 plus 13.7 plus 13.6. You divide by 3. This one will give us 13.63 centimeters cube. So that's how you get your 1 mark. The next question is calculate. The question starts here. Calculate the number of moles of compound B used. So you need to know what information of compound B that you are provided with, because you cannot be asked the number of moles if there is no any other information provided. So let us go back to what we were provided and check what we were given about compound B. Compound B, which forms solution B that we have used, was 0.05 molar compound B. So this solution B is 0.05 molar. That means you should know that 0 0.05 capital M simply means number of moles in 1 liter. This is capital M stands for molarity, and the molarity is the number of moles in 1 liter. Therefore, this one is in 1,000 centimeters cube of the solution B. That is the most important information we should have. Now, this means that 0.05 capital M is the number of moles in 1,000 centimeters cube of solution what? Of solution B. Because if we have number of moles in solution B, it is compound B that was formed, that formed solution B. So you should not worry about that. Now the question is number of moles of solution B used. How much of B did we use? Right? We pipetted 25 centimeters cube of B. So we will ask, if 0.05 moles are in 1,000, what about 25 centimeters cube of solution B? What will be the number of what? Moles. Now it is 25 times 6 divided by this, 25 times 0.05 divided by 1,000. That's, this one will give you 0.00125 moles. So that is the number of moles of compound B that reacted with C1, C2, right? Next one is calculate the number of moles of hydrochloric acid used. Hydrochloric acid used. Remember, hydrochloric acid used here is C2. Remember, we pipetted C1 into a 250 volumetric flask and then made a 250 solution C2, and it is the one we are using. So B to ratio C2 is HCl. You should know that. So the ratio, number of moles of HCl used if 1 mole of compound B react with 2 moles of HCl. So the ratio is 1 to 2. But we have the number of moles of B. So B is 0.00125 moles. So it is, if 1 equal to this, what about 2? So now moles of C2 used, right, equal to 0.00125 times 2, which is equal to 0.0025. That is the number of moles of C2 that reacted with B, 25B. But what was the volume of C2 that reacted with B? We have it here, the volume, the average. This is the average of C2 that reacted with B, solution B. It's important for you to understand that. Now the next question is calculate the concentration in moles per liter. Concentration is in moles per liter, it means actually molarity. Calculate the molarity. Concentration in moles per liter, in moles in 1 liter is molarity of HCl acid solution C2. Now we want to calculate the molarity of C2 in 1,000, but we have moles of C2 in 13.63. C2 that reacted with B, compound B, is 13, the volume is 13.623 centimeters cube. What about now this? So we'll ask here like this: 13.63 centimeters cube C2 has got these moles, 0.0025 moles. What will be the number of moles of C2 in 1,000, because we want moles in 1 liter. 1 liter equal to 1,000 centimeters cube. C2 will be equal to how many moles? So that one will be 1,000 times 0.0025. You divide by 13.63. This one is gonna give us 0.0 or 0.1, 0.1834. Capital M stands for molarity. So that is the number of moles of C2 in 1 liter. The next one is calculated the concentration in moles per liter of hydrochloric acid solution C1, the original. We want to calculate the molarity of solution C1 in the original. Very important. Now here, this way you need to understand it. Remember, we took 25 centimeters cube C1, put it into a 250 centimeters cube volumetric flask, right? We added water to the mark, meaning that we prepared, and this solution was called C2. We took C2. From here C2 we use 13. But remember this: the number of moles in 250, the number of moles in 250 C2 will be equal to the number of moles of 25 centimeters cube C1, the original, because moles does not change. Remember that. So moles in 250 C2 will be equal to moles in 25 C1. That is what you needed to understand. Now, we know that we have even the concentration of C2. We can even begin it there, or we will say 13.63 centimeters cube C2, centimeters cube of C2 has how many moles? 0.0025 centimeter moles. What about 250 centimeters cube C2? So if we have moles in C2, the volume is 250, we will automatically have moles of C1 in 25, the one we pipetted and diluted. So 250 times 0.0025, you divide by 13.63, and this one will give us 0.04585 moles. So this is the number of moles in 250 centimeters cube solution C2. But remember, moles in 250 C2 is equal to moles in C1, 25. So 25 centimeters cube C1 is equal to these moles. Moles is 0.04585 moles. Right? Now we will ask, what will be the number of moles in a liter? If 25 is this one, what about a liter? 1,000 centimeters cube C1 will be what? 1,000 times 0.04585, you divide by 25. This one is giving us 1.834 capital M, and that is the molarity of C1, the original solution C1. Part B, you are provided with 2 portions of solid D and sodium hydrogen carbonate, each weighing 2.5 grams. You are required to determine the heat of reaction of hydrochloric acid with aqueous sodium hydrogen carbonate. Procedure 1B. Using a 100 ml measuring cylinder, measure 30 centimeters cube of distilled water and place it in a 100 ml plastic beaker. Measure the temperature of the distilled water and record it. Table 3. Add one of the portion of solid D to the water. Stir the thermometer. Measure the minimum temperature reached. Minimum temperature reached. Record the reading. So the temperature of water in our case was 20. Then the final temperature after adding solid D, the temperature rose to 25. So temperature change, it is 25 minus 20, which will give us 5. Now calculate the, let us go to the question. So I'm saying that this temperature, these values here, every student will find it. Others will get 27 here 22. It depends on the temperature of that room. So these values are now actually they are not a constant. They can vary. Somebody can have 30 here. Any value can work here. Depending on those people who are in Rodwa, they will have a very different temperature. They can have even 35. So it depends. So don't look at this one, then you find yourself that you fail. No, you didn't fail. Calculate the heat change of the solution. Assume the specific heat capacity is this per degree. Density is this. But you should know that heat change equal to capital M, which is the mass of the solution, times specific heat capacity times temperature change. Temperature change. Now the mass of the solution, our solution, we measured 30 centimeters cube of distilled water. So you should know that 30 centimeters cube gram of water is equal to 30 grams of water. So 30 centimeters cube is equal to 30 grams. That one you need to know that. Therefore, our mass is 30 grams. But I want to convert this mass into kilograms by dividing into 1,000. Now I will have in kilogram. And then times specific heat capacity have been given here 4.2 times temperature change. My change in temperature is 25 minus this, which is 5. So this one is 0.003 times that, and this one will give us 0.63 kilojoules. Remember, those who got 7 here, they will do the same and they will get a mark. Those who have even 10 here as the temperature change, they will still score the marks. So we don't need to have anything. The thing is, how did you use your value, this value? Did you use it correctly here? Yes, and that is how you get 1 mark. Number of moles, calculate the number of moles of hydrogen, sodium hydrogen carbonate, solid D. Used relative formula mass of D is 84. But we know that moles equal to mass over R FM. Our mass was 2.5 grams divided by 84. That one will give you 0.02976 moles. 0.2976 moles. Calculate the heat change H1 in kilojoules per mole of sodium hydrogen carbonate. Now you need to understand this. This amount of heat, 0.63 kilojoules, were produced by this number of moles. So we are going to ask if this moles was able to produce 0.6 kilojoules, what will 1 mole, because we want heat change per mole. What about 1 mole? So we want to say that 0.02967 moles produced 0.63 kilojoules. 1 mole will produce what amount? So it is 1 times 0.63 divided by 0.02976. 76. I think I have written wrong. Let me check. Yeah, 0.2976 is this moles. What about 1? So this divided by this will give us 21.169 kilojoules per mole. But now the next thing we need to ask ourselves is whether the reaction was exothermic or endothermic, because by leaving the answer like this, you will not score 1 mark. In fact, I don't know whether you will score even a half. Therefore, this reaction, we want to know whether it was exothermic. How do you know? temperature rose from initial temperature 20 to 25, something like that. Temperature was increasing, therefore the reaction is exothermic, and therefore you should indicate that the reaction is exothermic by putting a negative. So negative 21.169, and that is the correct answer that was required. So yours could be negative 30 point something negative. So the thing is, do you know, did you understand that exothermic reactions, this negative sign indicates an exothermic reaction? Is the thing. Procedure 2B was similar, but the difference is that we were using 30 centimeters of solution C1 HCl instead of distilled water. So I will so it is the same. That's why I've skipped some steps, because we know how to do that. Divided by 0.02976, and the reaction is negative 25.403 kilojoules per mole. So the thing was now number 3, Roman 3, heat change. Calculate the heat change H3, which is equal to change in H2 minus change in H1. Therefore H3 equal to change in H2, we have H2 negative 25.403 minus, but whatever we are subtracting is a negative 21.69. Therefore a negative 25.403, negative would be positive 21.169, and the final answer should be negative 4.234 kilojoules per mole. So that one is H3. Number 2, you are provided with an organic compound, solid M, organic. You have been told it is an organic compound. Carry out the following test and record the observation and inferences in the spaces provided. Place about 1/5 of the solid M on a metallic spatula and burn it using a Bunsen burner flame. So what happened? Solid M burns, melt first, melts and burns with a yellow sooty flame. That definitely tells you that it is an alkene or an alkyne present. The double or the triple present. Someone else can say an saturated organic compound present. Unsaturated organic compound present. This one is fine, this one is also fine. Place the remaining amount of solid M in a boiling tube. Add about 15 centimeters cube of distilled water and shake to dissolve. Use 2-portion solution to test for this. The first test is, to the first portion, add 3 drops of acidified potassium dichromate. Warm the mixture. So what happened? The orange acidified potassium dichromate remains orange after warming or on warming. So the color did not change. we expected it to change from orange to green, indicating that there is an alcohol. But it did not change, therefore it remained the same. It means that the alcohol is absent, or was absent. The alcohol was absent. Alcohols was absent. So the second portion, add 3 drops of bromine water, and bromine water is decolorized, or you write that the color of bromine water changes from yellow to colorless. That is what it means. Then it means that the double bond or the triple bond is present. The third portion, add all the solid sodium carbonate provided. Test any gas produced with a burning splint. So what was the observation? Effervescence, gas producing a gas which extinguish a burning splint. So it means that carbon dioxide was produced. So some people maybe could imagine to write that CO3 minus present, but remember we are in organic chem, so we don't want to write anything that is inorganic. Therefore, this is what it means. It means that this carbonate, sodium carbonate, reacted with an acid to form to produce a gas which is carbon dioxide, right? That's correct, because this gas was confirmed by extinguishing the burning splint. So you don't have to tell us that it is the carbon dioxide gas produced. No, already we have said a gas has been produced. Therefore, the correct inference is that the solution was acidic, and the acid was organic acid. This is the functional group for alkanoic acids present.